Hey everyone, in this video we're going to look at the next quadrilateral that we are going to study this year, and that's the parallelogram. So a parallelogram has all the properties that a trapezoid has and a bunch more of its own. So we're going to look at all those properties now. So first we're going to graph the parallelogram MATH with the coordinates given, and we're going to calculate the slope of each side. So the same way as anytime we have the coordinates in a graph given, we're going to plot those. So M is at 4, 3. Then we have A is at 6, -1. T is at 0, -1. And H is at -2, 3. Okay, so there's our parallelogram. So first thing we said we were going to do is calculate the slope of each side. So if I look at the slope of MA, well, I'm going down 4 over 2, right? So that would just imply to -2 over 1. So it checks out if I go down 2 over 1 each time as well. AT is just 0, right? Any horizontal line is going to have a slope of 0. TH is also -2 over 1, or just -2. And finally, MH is equal to 0. Notice how I did this? I labeled each one. I made it clear. That's what I'm expecting you to do when we eventually get to the quest on this unit. You were supposed to be doing it from the previous unit as well, but really this is where it's going to be really important that we label the side we're talking about, what slope we're doing, what formula and everything. So make sure that that's clear. And then after we have that, we should notice MA and TH have the same slope, and AT and MH have the same slope. So we know that the opposite sides, right, if I look at MH and AT, and I look to TH and MA, the opposite sides are parallel. Remember, that's what slope shows us. If you have the same slope, they are parallel. So we know it was slope formula, so we know we were either going to be parallel or perpendicular. In this case, same slope, so parallel. Based off this, we also know that the consecutive angles are supplementary. So what I mean by supplementary, we know supplementary is two angles that add to 180. But what I mean by consecutive is one after another. So like if I'm at angle M, the next angle is A, right? And we talked about that on the last lesson with trapezoids, that the two angles that are in between parallel lines, they're on the same side here. So they're same side interior. So those are supplementary. So that would go for this pair here, which means this angle and this angle would also follow that same pattern. It's true if I went to the other pair of angles as well. Like if I look at angle A and then look at angle T, well, these two are parallel as well. So it's same side interior again. So basically, we know that both pairs of those angles are going to add to 180. So everything around there is going to equal 180. Okay. If that's true, if I think about it, if this angle and this angle have to equal to 180, and then angle T and angle H have to add to 180, and angle H and angle M, like if that's the case, if we know that angle T is the same in both the pairs of like A and H, we know that angle H is going to have to be the same as angle A because there's only one number. Remember, we talked about that rule earlier in the year. There's two separate angles that are congruent. I'm sorry, if there's two separate angles that are supplementary with the same angle, then they're going to have to be the same. Like let's say angle T for a second. Let's just say that that was 100 degrees. Then A would have to be 80, and so would H. Okay, and then once we know one of those angles, then we know we could figure the other angle out. But basically, we know that the opposite angles are also congruent in this case. And we'll look at that a little bit in a second. So for now, the next thing I'm going to do is calculate the length of each of these sides. So the nice ones, I'm going to get NH and AT out of the way. Because if I look at NH, we're going to use the distance to calculate the length. But MH, I'm just counting boxes, right? 1, 2, 3, 4, 5, 6. So MH has a distance of 6. You can count horizontal and vertical lines. So I'm going to do the same thing. 1, 2, 3, 4, 5, 6. So I got those two out of the way right off the bat. Now I'm going to go and calculate the other two. So I'm going to calculate MA. So anything that's slanted, that means we have to use our distance formula. So I know MA is going to involve 4 subtract 6 squared plus 3 subtracted -1 squared. So we're looking at -2 squared, which is 4, 4 squared, which is 16, and we get the square root of 20. You could simplify that to 2 radical 5, but we were in x2, so I'm not going to. And then we have one last side to calculate. So TH, when I look at that, we're looking at 0 subtract -2 squared plus -1 subtract 3 squared. So we get +2 squared, which is 4, -4 squared, which is 16, and we get the square root of 20 again. So if I look at this, the opposite sides are congruent. So I can show that sides are congruent by having equal length, so the distance formula. I could show sides are parallel by slope formula. So right now I know a parallelogram has opposite sides that are both congruent and parallel. Now it says draw the diagonals for the parallelogram. So if I draw these diagonals, remember they're across from each other. HA and MT are going to be diagonals. And then it says to calculate the midpoint. So I'm going to get MT. Remember, it's like through the midpoint formula. We'd have 4 plus 0 divided by 2, comma, 3 plus a -1 divided by 2. Let me make sure I had that. Yep. So my midpoint is going to be 2, 1. And I'll do the same thing for AH. AH, the points would be 6 plus a -2 divided by 2 and -1 plus 3. And again, we end up with 4 divided by 2, which is 2. 2 divided by 2, which is 1. So notice the midpoint's the same. So let's think about what a midpoint does for a second. A midpoint cuts something in half. Also, it's known as it bisects something. So anytime you have a parallelogram, the diagonals bisect each other. So we just recapped all of our rules. We started with slope, then we did distance, then we did midpoint. But that's because, like I said in the beginning here, parallelograms have a lot of properties. All of those properties we've just proven to be true. And that's what we'll see on this next page. So it has all the trapezoid properties. Really, the trapezoid properties, if we recall, was only that they have one pair of parallel sides. So that's true, right? At least one pair of parallel sides. So we have the trapezoid properties. We just showed that the diagonals bisect each other. So that means these two pieces are congruent and these two pieces are congruent. The opposite sides are parallel. So remember, that's the arrows. We showed that with slope. We showed that opposite sides were congruent as well. We showed that with the distance formula. Consecutive angles we showed were supplementary, so we know that the two angles next to each other in order, they're going to add up to 180. And that being said, then we knew that the opposite angles were congruent as well. Okay, because there's only one way. If we know that everything's going to be supplementary around consecutively, then no matter what that angle is, it's going to have to be the same as the next angle coming. So opposite angles are congruent. So let's try some of these properties into a problem here. If we had a parallelogram ABCD and AC and BD intersect at point L, if AL is equal to x minus 2 and AC is equal to 3x minus 16, then which of the following represents CL? I'm going to sketch myself a parallelogram here. Now, I know I talked about it the other day, but if you're going around and labeling A, B, C, D, it doesn't matter which point you start from A. It doesn't matter which point you go around, but you have to go around circularly. I can't do like A, B over here, and then C, D, and like crisscross like that. That can't happen. It's got to go in an order around. Okay, and then I also had AC drawn in and BD, which makes sense because look, if I don't have the diagonals drawn in correctly, then those don't exist, AC and BD. So we have to make sure we're good. This intersection point is L. Okay, then we know AL is x minus 2. And we know AC, this entire thing, is 3x minus 16. So this one directly involves diagonals. So we should be thinking about what the diagonals do. They bisect each other. So that means 3x minus 16 is equal to, since these two pieces are congruent, 2 times x minus 2. Okay, and then we're going to solve. Be careful that we're looking for the length of CL, which CL is this piece here. So it means it's the same as AL. So I'm doing 12 minus 2 to get 10. Don't fall for the trap there. Make sure that you plug it in to find CL, not that we just found X and we were good. Okay. If we have another parallelogram, MNPQ, side MN is 7 inches longer than twice the length of NP. If the perimeter of MNPQ is 68, then which of the following is the length of NP? So again, I'm going to recommend that we draw a parallelogram. Now, it never has to be drawn to scale. You never will get points off for what you draw, but you do have to write these in order, like M, N, P, Q. Okay, and we know that MN is 7 inches longer than twice the length of NP. So that means NP, we're going to call that X, and MN will be 2X plus 7. And we know the perimeter, if I add up all the sides, it's equal to 68. So that's what we know. The pieces that we have to keep in mind is that we just said that the opposite sides are congruent. So that means this is 2X plus 7, and this piece is X. We take that, and we're going to add everything up now. 2x plus 7 plus 2x plus 7 plus x equals 68. Okay, and you could have just done 2 times 2x plus 7, 2x, whatever you want to choose in that case. But we're going to get 6x plus 14 equals 68. 6x equals 54, and x equals 9. Now then I just look to plug this back in, but NP is equal to X. So I'll finish it off by saying NP is equal to 9. Okay. One last one for this. We have parallelogram ABCD has the coordinates A, B, and C given. We need to figure out what coordinate D has to be to make sure it's a parallelogram. So let's plot the ones we have. 7, 1. -2, -3. Okay, so we have 3 out of the 4. Now, keep in mind what I was just talking about. When we draw these in, like when we talk about this, I have to write it so D is somewhere in this area, right? Like D can't be on the bottom over here. It's got to be, so they're in order. So that's one thing we know. So I'm going to connect the pieces that we have, like CB and AB. So we're missing one last point to make this work. Well, you could do a bunch of things, right? You could calculate the distance. You could calculate the diagonals, figure out where they would meet. But really, the easiest one here is going to be to use the slope, right? So you could calculate either slope or both, right? I can go ahead and say that AB has a slope. So if I'm counting AB, I'm counting up and over, right? So I counted up 1, 2, 3, 4, over 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to do that same exact slope from C. So from B to A, when I read this, I had that slope of 4, 9. Then I'm going to do the same thing from C. So I'm going to count up 4 over 9. That's going to be the point that makes this a parallelogram. Okay, so it already looks the part, right? Because then now CD has a slope of 4, 9, and we could check the other two to make sure they're good as well. So if I look at BC, which I knew before, BC has a slope of 1, 2, 3, 4, 5, 6 over 2. Simplifies to 3. And if we look at AD, slope is 1, 2, 3, 4, 5, 6 over 2. Also simplifies to 3. So we know they're equal lengths apart from each other, but if you could show that both pairs of opposite sides are parallel, then we know here. So D is at the point, because it says strictly what's the coordinates? 9, 7. Okay, and we're going to say parallelograms have both pairs of opposite sides congruent. Oops, sorry, that's not what I just did. That would be a classic mistake of me. You can't write that way. I say parallel, right? Even though we could prove they're congruent, we can't say that because we didn't use the distance formula. So make sure we're only talking about, since we use the slope here, oops, sorry about that. We use the slope. That means we can only talk about parallel. Okay, so then we can find that missing point. All right, guys, we'll keep talking about more quadrilaterals as we go further in this unit. But other than that, thanks for watching.